In this lesson, you'll learn how to access weather services and reports to plan and fly safely to your destination. Now, to that end, you're going to have to learn how to read weather forecasts and reports. In this lesson, you will also learn how weather forecasting is the application of science and technology to predict the state of the atmosphere for a future time and a given location. Welcome to lesson number 2, Weather Services. Now, in aviation, weather forecasts, briefings, reports, and charts are a combined effort of the National Weather Service, the FAA, the Department of Defense, and other aviation groups and individuals. With the internet, you now have access to worldwide weather services as well as local and regional reports. While weather forecasts are not 100% accurate, through careful scientific study and computer modeling, meteorologists have the ability to predict the weather patterns, trends, and characteristics with increasing accuracy. Through a complex system of weather services, government agencies, and independent weather observers, pilots receive the benefit of this vast knowledge base in the form of up-to-date weather reports and forecasts. These reports and forecasts enable you to make informed decisions on your mission, route of flight, go-no-go decision, and en route operations. Now, when planning a flight not in the vicinity of an airport, the regulations require you become familiar with weather reports and forecasts for the route of flight, although it's recommended you check your weather as part of all your pre-flight preparations, regardless of how far you're flying. In this lesson, we'll discover how you obtain weather information prior to and during flight, as well as what weather services are available to you. You need to understand the various reports and forecasts available so you know which ones to refer to for the information you're seeking, as well as how to read and use them. There are many services available to help you plan a safe flight and avoid rough weather that may be along your intended flight route. We'll start out by discussing these topics: METAR, TAF, area forecasts, PIREPS, winds aloft, in-flight advisories, EFAS, convective outlook, surface analysis, weather depiction, radar summary, constant pressure, and significant weather prognostics. Okay, those are your topics for this lesson. Let's get after the first topic, METAR. Join your instructor in the classroom.
Hi, in our first topic, we'll review pre-flight weather briefings. While it does take a little time, skipping this task is not a good idea and may even compromise safety. Knowing what to expect on your flight also makes the flight a whole lot more enjoyable. Prior to every flight, you need to consider the entire flight, including the departure airport, route of flight, destination, and alternates. You should gather all information vital to the nature of the flight. Not only is it important to know if the weather conditions are suitable for your type and flight mission, but a weather briefing is also necessary to select your route and altitude of flight. Calculate your performance and complete a flight plan. You can begin by looking out your window, watching the local weather station on your television, or reading the newspaper. And finally, obtaining a complete weather briefing via telephone or the internet. First, we'll talk about obtaining a weather briefing over the phone. You can call 1-800-WX-BRIEF from any phone 24 hours a day and talk to a weather briefer. To begin, you need to identify yourself as a pilot. In addition, you need to provide some basic information as part of your weather briefing request, including planned flight. Are you going to fly VFR or IFR? Aircraft identification and type. Are you flying a Cessna 172 or a Lear 60? Your name and your departure, route, and your final destination. Altitude. Are you flying at 2,500 feet, 10,500 feet, or 39,000 feet? Take a look at the minimum en route altitudes for your route. Departure time. When are you leaving? Time en route. How long from point A to point B? Estimated time of arrival. When are you going to arrive? Now, there are different briefings you can request when you speak with a weather briefer. The Outlook briefing encompasses 6 or more hours in weather conditions in advance of your proposed departure time. Request an Outlook briefing if you're calling 6 hours or more in advance of when you actually plan on lifting off. The standard weather briefing provides a complete weather history for the briefing of your planned flight, what the conditions are when you take off, while en route, and at your destination and alternate. Request a standard briefing to get a complete weather briefing. An abbreviated weather briefing is used primarily to update a previous briefing, either the Outlook or the standard, to supplement or to add to information you already have, like new winds aloft information or new temperature information for your route of flight or for your arrival. Request an abbreviated briefing to supplement mass disseminated data or when you only need 1 or 2 items. Here are definitions for weather conditions you will encounter with weather reports and charts. Visual flight rules, or VFR flight, means a ceiling greater than 3,000 feet and visibilities greater than 5 miles. Marginal VFR is the ceiling between 1,000 and 3,000 feet and visibilities anywhere from 3 to 5 miles. Instrument flight rules, or IFR, is defined as a ceiling of 500 to less than 1,000 feet and visibilities of less than 1 to 3 miles. If you are a VFR-rated pilot, or if your airplane is VFR equipped, you cannot fly when IFR weather conditions exist. Likewise, an IFR-rated pilot may not operate IFR unless you're using an IFR-equipped airplane and have filed an IFR flight plan.
Now, we are very pleased this morning to have Tom Horn with us in the studio. Tom is a prolific writer and an avid pilot with an affinity for understanding the workings of weather. He has more than 4,000 hours of experience in some 200 different airplanes. He has an ATP and flight instructor certificate and more than 2,000 magazine articles and numerous journalism awards to his credit. He's written on the subject of aviation weather regularly for over 20 years, including his book, Flying America's Weather. Tom has written for AOPA Pilot magazine for more than 25 years and is a regular presenter at trade shows across the country. Tom, welcome and thanks for being here.
Well, thanks for having me.
Good. Now, your logbook includes lengthy stints as a flight instructor, a photogrammetrist pilot, and a transatlantic ferry pilot with numerous crossings in single and multi-engine airplanes. Now, with all that experience, what is your primary concern about weather?
I'd say it would change with the mission. If you're doing some flight instruction, well, it depends on the student and where he's at in the curriculum. If he's beginning, he won't be able to tolerate much in terms of crosswind or adverse conditions, and you want to have ideal conditions. If he's farther along in the program, then you'd want to take on crosswinds or more challenging weather situations. Same thing with instrument training. Try to do some gradual immersion and get him involved in a look at deteriorating weather conditions from the front seat with an instructor.
A ceiling is defined as the height above the Earth's surface of the lowest layer of clouds or obscuring phenomena like fog or haze. The next topic for discussion is METAR, or Aviation Routine Weather Reports. METARs are available from DUWATS or other services. DUWATS is a system that allows you to use your personal computer to access weather information. Flight service stations, internet weather, the National Weather Service, and uplinked cockpit weather. METARs are a report of the surface weather reported in a standard format. It's compatible with all international aviation reports. Back in the 1980s, all of the international aviation agencies got together in Canada and came up with one way to report weather for all pilots across the world. So we all speak one language. It's easier to read, less is implied, and more is spelled out explicitly. There are a number of different types of METAR reports available. Now, METAR is a routine report, and SPECI is a special report. Now, typical METAR reports look like this. METAR, that's the type of report. KINK is the identifier in Winkler County, Texas. There's the time of the report. You have your wind information, your prevailing visibility, and there's a runway visual range. Weather conditions, the temperature dew point spread, the altimeter or barometer, and a remarks section. Now let's break this down and see how to read a METAR. Now first, check the ICAO airport identifier. In this case, KINK is Winkler County, Texas. There are region identifiers. Now, if there is a K in front of this, it's in the continuous lower 48 states. If you see PA, it's in Alaska. And if there is a PH, it's in the state of Hawaii. Now, here's a look at the time. It is 1845 Zulu on the 12th day of the month. The winds look like this. The wind is 110 degrees at 12 knots with gusts up to 18 knots. Now, here are the wind codes. The V denotes wind direction that varies by 60 degrees or more. So, in this case, the winds are variable between 90 and 160 degrees. VRB04 means the winds are variable to 4 knots. 000 KT means the winds are calm. 15 SM is the visibility, that is 15 statute miles. Here's the runway visual range. Runway 32 left, 1,200 feet. There's another runway in this case. It is runway 6 left. Now the visual range here is 2,000 feet, variable to 4,000 feet. An M in the runway visual range means less than, and the P means plus or greater than. In this case, it is runway 6 left. Visual range less than 600 feet because there is an M listed. For sky conditions, SKC means sky conditions are clear. SKT indicates sky conditions are scattered clouds at 4,500 feet. OVC means overcast sky conditions. In this case, it's overcast at 4,500 feet. TCU means there are towering cumulus clouds, and CB indicates cumulonimbus. These are the only types of clouds identified on the METAR. For example, here you see OVC, an overcast layer at 1,000 feet, consisting of a cumulonimbus cloud. There is also a broken layer, as indicated by BKN at 4,500 feet, consisting of a towering cumulus cloud. Now, here you see VV008, which means indefinite ceiling with vertical visibility at 800 feet. If you see VV with these slash lines, in the sky conditions, it means indefinite ceiling with vertical visibility undetermined. Here is the temperature and dew point. Temperature is 25 degrees Celsius, dew point 17 degrees Celsius. Now remember, 1 degree Celsius equals 1.8 degrees in Fahrenheit. When you see something like this, 10-M06, it means the temperature is 10 degrees Celsius, but the dew point is -6 degrees Celsius. Now here are the temperature remarks. Temperature 17.6 with a dew point here of 15.8. This is indicating there is a very close temperature dew point spread, which suggests that fog could be occurring. Altimeter setting A3000, that's our altimeter or our barometer in inches, 30.00. Under remarks, you see SLP013, which indicates the sea level pressure is 1,013 millibars. Now here are some modifiers you might see on a METAR. You have obstructions to visibility, FG, fog, less than 5/8 of a mile. BR is mist, visibility anywhere from 5/8 to about 6 miles. FU, fume, that's kind of the French way of saying smoke. HZ is haze. SA means sand. DU, dust. And VA, volcanic ash. Now, types of precipitation you're going to see on a METAR include RA for rain, DZ is drizzle, SN means snow, SG means snow grains or snow granules, GR indicates hail greater than 1/4 of an inch in diameter, GS means small hail or snow pellets, and IC is ice crystals. Now you can find a complete listing of contractions and acronyms used in Advisory Circular 00-45, Aviation Weather Services, available online and in print. Now here are some modifiers to go with the METARs. When you see a minus sign, it means light. For example, light precipitation or light turbulence. And of course, a plus sign means heavy amounts of something. In this case, a plus SHRA. So that's heavy showers or rain. Descriptors on a METAR include FZ, so that means freezing, SH, showers, and TS means thunderstorms. This is an automated weather report. A METAR is created totally by an automated weather observation station. So no humans do this. It's an automatic device.
Okay, we have 3 review questions for you this time. First one, to get a complete weather briefing for the planned flight, the pilot should request which of these 3? Your answer is C, a standard briefing. You should request a standard briefing anytime you're planning a flight and you have not received a previous briefing or preliminary information through mass dissemination media. All right, let's take another question. We want you to consider the bolded portion of this report here. Our question is, what does the VV008 signify? You have 3 potential answers. We can help you out a little bit here with the next slide. VV008 signifies sky condition indefinite ceiling with vertical visibility indefinite at 800 feet. We go back to our question. Our answer then is B. Make sense? Okay, let's take a look at our final question for this topic. Again, consider the bolded portion of the report. Question, what does the 15SM signify? 15SM. What does that signify of these 3? Help you out a little bit with this slide here. 15SM, visibility 15 statute miles. We go back to our question. The answer then is C. Okay, that's it on that topic. Let's move along. Next up, TAF. Back to your instructor in the classroom.
Next, we'll cover forecast. While checking the weather forecast on TV or the radio is always a good idea, pilots use a formal language to ensure we understand forecasts specific to aviation. Let's talk about the Terminal Aerodrome Forecast, or TAF. This is an excellent source for forecast weather at a specific airport. As with a METAR, plain language reports are also available online. Now check out this online example. TAFs are valid for a 24-hour period of time in most places and 30 hours at some airports. Scheduled 4 times a day at 000 Zulu, 0600 Zulu, 1200 Zulu, and 1800 Zulu time. While you need to learn how to read both METAR and TAFs to pass your knowledge exam, it's also important for you to know plain language reports are available to you online. There are similar codes as those used in the METAR reports. They are usually routine forecasts. An amended TAF may be issued when the current TAF is no longer as expected. TAFs use this format. You have type, location, issuance time, valid time, and the forecast. However, a TAF can be amended if conditions warrant. An amendment is issued when the forecast is no longer as expected. A TAF amended looks like this. TAF AMD. If the forecasters have made a correction, it is TAF COR, or the TAF has been delayed and you are still waiting for information to go into that forecast. It's a TAF RTD. Now here's the TAF sequence. They are issued in the following format. You have type of report, location, issuance time, valid period, the forecast, and any temporary conditions. Now here are the forecast change groups. This section translates like this. You have Oklahoma City, 5th day of the month at 11:30 Zulu. The effective time is from 1200 Zulu on the 5th day of the month until 1200 Zulu on the next day. A TAF is good for 24 hours in most places, but may be valid up to 30 hours at some airports. Wind from 140 degrees at 8 knots, visibility 5 statute miles. Sky condition broken at 3,000 feet. Tempo sequence translates to this. Temporary conditions at 1300 Zulu to 1600 Zulu, 1.5 statute miles in mist. FM 1600 here means from 1600 Zulu, winds will be 160 degrees at 10 knots, visibility greater than 6 statute miles. No significant weather indicated by NSW, and sky conditions are going to be clear. BECMG means becoming. So becoming from 2200 Zulu to 2400 Zulu, the wind is now 200 at 13, gusting to 20 knots. Visibility 4 statute miles. SHRA indicates rain showers. Sky conditions overcast with 2,000 feet. Here's the next one. Probability. There's a 40% probability that the conditions between 00 Zulu and 600 Zulu will be visibility of 2 statute miles in thunderstorms and rain. Sky conditions overcast with cumulonimbus bases at 800 feet. Probability 40% at around 00 to 600 Zulu, 2 statute miles, having some thunderstorms overcast with our bases of the cumulonimbus at 800 feet. And then becoming from 0600 Zulu to 800 Zulu, winds 210 at 15 knots, visibility is greater than 6 statute miles. Becoming at 0600 Zulu to 0800 Zulu, 210 at 15. Our wind direction and our wind speed. There we are at 6 statute miles. No significant weather, NSW. Then we have our sky conditions down there, scattered at 4,000 feet. TAF time periods. At tempo 0513/0516. This means temporary conditions on the 5th day of the month, 1300 Zulu to 1600 Zulu. From 1600 Zulu, then becoming 2200 Zulu to 2400 Zulu, and probability 40% from 600 Zulu becoming 600 Zulu to 800 Zulu. That's how the TAF translates.
Okay, let's have a review question on the terminal area forecast. What is the valid period for the TAF for KMEM? The valid period. You have 3 potential answers. Let's take a look at the TAF on the KMEM area. Zooming into that 6-digit number there should give us our answer. We come back to A. The valid period is the 4-digit group of the forecast in UTC, usually a 24-hour period. This figure uses a 6-digit group and includes the date. The valid period for KMEM is a 24-hour period from the 12th of the month, 1800 Zulu, to 1800 Zulu the following day. All right? Another question here. Consider a TAF that begins with TAF AMD KOKC. What does the AMD mean? Which of these 3 is the correct answer? The answer is B. TAF AMD means an amended TAF. The forecast has been changed slightly. All right, let's tackle yet another topic here for you. This time out, area forecasts. Back to your classroom.
The area forecast is a forecast of general weather conditions over an area the size of several states. It's used to forecast and route weather and to interpolate conditions at airports that don't have a TAF issued. Here is an example of an area forecast. The area forecast is issued 3 times a day and is comprised of 4 sections: a communications and producer header section, precautionary statement section, and 2 weather sections, synopsis and VFR, clouds and weather. Now check the area forecast for Indiana. The forecast is coded similar to METAR and TAF reports. Note the forecast is located on the bottom section of this chart.
Okay, let's take one review question for you on area forecasts. What is the outlook for the southern half of the state of Indiana after 0700 Zulu time? 3 potential answers. Let's look at the area forecast here. Down at the bottom, we have the southern half. We zoom in. Outlook, VFR, it translates into the southern half, covers Indiana. AGL, of course, means above ground level. SCT, scattered. 5,000 feet scattered, broken at 10,000 feet. The tops are 120 or 12,000 feet. At 0700 Zulu, AGL scattered at 3,000, scattered at 10,000. Outlook VFR. So it translates into the southern half of Indiana. After 0700 Zulu is going to be VFR. Your answer is B. Okay, next up. PIREPS. Join your instructor again in the classroom.
Pilots experiencing the actual in-flight weather conditions are one of the best sources for real-world aviation weather.
So right now we're flying out at 2,800 all the way up to 6,000 feet on a heading of 020.
Let's talk about pilot reports, also called PIREPs. A PIREP is a report given by a pilot while in flight, and they provide real-time weather information. You're encouraged to give PIREPs as they are useful for weather briefers to aid fellow pilots who might be flying along your same route. Here's a PIREP and a key to deciphering what it means. UA indicates it's a routine report. OV is the location and distance out from a radial. TM is Universal Coordinated Time. The FL, flight level for icing and turbulence. TP, type of aircraft for icing and turbulence. SK, the sky coverage. WX is the weather. TA is the temperature in Celsius, the wind direction and speed. W for wind. V for velocity and speed. TB, turbulence and the intensity and where it was encountered. Icing, IC, and RM is remarks. Smooth ride, beautiful day, something like that you can put at the end. So here we have our PIREP. They're over Oklahoma City on the 063 radial out at about 64 miles. Time 1800, that is Universal Coordinated Time. Flight level 120 at 12,000 feet. Type Beach King Air. Temperature is -7 degrees Celsius. The wind is 80 degrees out of the east at 21 knots. Turbulence light between 5,500 and 7,200 feet. Icing light to moderate rime ice. A little choppy, and they're encountering some rime ice.
All right, let's move along to another topic. This time, winds aloft. Back to the classroom and your instructor.
It's important to know if you're going to have a headwind, a tailwind, or a crosswind, both for planning our headings as well as time en route, necessary to calculate the fuel required for the flight. It's also important for you to know the temperatures at your flying altitude, as this will affect the performance of your airplane and the likelihood of icing while in clouds. The winds and temperatures aloft forecast is displayed in a 6-digit format and shows wind direction, wind velocity, and the temperature that is forecast to exist at specified levels. No winds are forecast for a level within 1,500 feet of the surface, and no temperatures are forecast for the 3,000-foot level or for a level within 2,500 feet of the surface. The wind direction is shown in tens of degrees with reference to true north, and the velocity is shown in knots. Temperatures are in degrees Celsius and are negative above 24,000 feet. Each 6-digit group includes winds and temperatures. Now let's take a look at an example. Now here's a close-up. Note the graphic depicts what's currently on the FAA test at the time of production. It, however, is now referred to as FB. Let's continue. The data is based on the 15th day of the month at 1200 hours or at noon Zulu time. Valid through 1600 Zulu time. Used for 1800 through 0300. On this side are all of the station identifiers. FT simply means 3,000, 6,000, 9,000, 12,000, and 18,000 feet. Let's take a look at DEN. That's the 3-letter identifying code for Denver, Colorado. Here we have 2321-204. This means the winds are 230 degrees true. They're out of the southwest at 21 knots. And the temperature is 4 degrees below Celsius. If the wind is forecast to be between 100 to 199 knots, the wind direction portion of the code will be greater than 50. In cases such as this, you need to subtract 50 from the coded wind direction and add 100 to the coded wind speed to decipher the code. So here's an example. If the forecast for 39,000 feet is 731960, subtract 50 from the 73 and add 100 to the 19. This will give you a forecast wind of 230 degrees and 119 knot wind speed where the temperature doesn't change. It's still -60. One more time. If the wind is forecast to be between 100 to 199 knots, you subtract 50 in the direction and add 100 to the speed. So once again, we have 230 at 119 knots at a temperature of 60 degrees below zero. In cases where the wind speed is 200 knots or greater, the wind speed will be indicated by 99. In this case, you will again need to subtract 50 from the coded wind direction and translate the 99 into greater than 200 knots. When you see a 9900, it means the winds at that elevation are light and variable, or they are less than 5 knots. The observed winds aloft chart shows temperature, wind direction, and speed at selected stations. Arrows with pennants and barbs indicate wind direction and speed. Each pennant is 50 knots, each barb is 10 knots, and each half barb is 5 knots. Wind direction is shown by an arrow drawn to the nearest 10 degrees, with the second digit of the coded direction entered at the outer end of the arrow. So a wind in the northwest quadrant with the digit 3 indicates 330 degrees, and a wind in the southwest quadrant with the digit 3 indicates 230.
How do you ever feel safe flying an IMC? And do you have a simplified way of checking weather data before a flight to make a basic assessment of the icing danger?
Yes, you have some tools now on the internet. ADDS has an icing page on their site, and what you can do is you can go on there and then look at the current icing potential or forecast icing potential. The abbreviation is SIP and FIP, and you can select an altitude, and it will give you a percentage of probability of icing conditions at that altitude. It will also identify areas of supercooled large droplet icing conditions. So that's one tool, and it's one that I always check. Getting back to the pilot and experience factors, that's something else that weighs into the balance, as well as the airplane. Are you going to be able to top cloud layers safely? If you're turbocharged, yes, probably. If you're not, well, then it's probably time to turn around at the first sign of ice. You should always be, in the wintertime or whenever colder temperatures are out there, you should always be looking at the airframe for the first signs of ice buildup. You should also always look at the OAT gauge. A lot of pilots eliminate this from their scan, and then they're surprised when they suddenly realize that there's ice on the airplane, when in fact they've been flying in freezing or sub-freezing conditions for many minutes. So I would say to include the OAT in the scan. But to number one, anytime there's colder temperatures aloft, to have an alternate plan in mind in case icing does occur. This means turning around, descending, climbing. Descending is usually the better option if there's no terrain involved, because the warmer temperatures presumably would be below the cloud base, or at least you'd be out of the clouds and not building any more ice. The main thing is that you want to lose ice as you descend and not pick up any more of it.
Okay, let's take time for another review question. Refer to the wind and temperature aloft forecast we'll show you in a sec. What wind is forecast for St. Louis at 9,000 feet? Okay, you have three potential answers there. This is our forecast. Across the top, we have the altitudes. Across the left side, there's St. Louis down at the bottom. We intersect that at 9,000 feet. We have the coded four-digit wind forecast is 2332. Thus, the wind is forecast at 230 degrees true at 32 knots. Back to our question. Our answer then is A. 2332 decodes to 230 degrees true at 32 knots. That's your answer. Next topic. In-flight advisories. Let's join the instructor back in your classroom.
Once airborne, your pre-flight weather briefing may not actually reflect the actual conditions you encounter. For this reason, pilots are encouraged to obtain weather while in flight. In-flight weather advisories warn en route pilots of the possibility of encountering hazardous flying conditions that may not have been forecast at the time of the pre-flight weather briefing. There are three kinds of in-flight weather advisories: airmets, sigmets, or convective sigmets. Significant meteorological information, or sigmets, advise pilots of potentially hazardous weather to all categories of aircraft. Doesn't matter if you're a J3 Cub or a Boeing 747, this includes everybody. Severe icing, not associated with thunderstorms, are included with sigmets. Severe or extreme turbulence or clear air turbulence, dust storms, or volcanic eruptions reducing visibilities under 3 miles. Airmen's meteorological information, or airmets, advise pilots of significant weather, but at lower intensity than sigmets. So maybe this is important if you're flying a J3 Cub or a Cessna 172, but not quite as important if you're flying a 747. An AirMet will indicate moderate icing, not severe icing, moderate turbulence, sustained surface winds of 30 knots or more, ceilings less than 1,000 feet, and visibilities less than 3 miles over more than 50% of the area. A convective SIGMET alerts pilots of tornadoes, lines of thunderstorms, thunderstorms over a wide area, embedded thunderstorms, wind gusts to 50 knots or greater, and or hail 3/4 of an inch in diameter or greater. Besides in-flight weather advisories, weather briefings are also available while airborne. Let's check these out now. A source for in-flight weather advisories is known as En Route Flight Advisory Service, or EFAS, also called FlightWatch. You can call FlightWatch on 122.0 when flying between 5,000 feet AGL and 18,000 feet AGL. FlightWatch will provide weather advisories pertinent to your route of flight, altitude, and type of aircraft you're flying.
Wind variable at 4, visibility 10, sky clear below 12,000, temperature 7, dew point 3, altimeter 3021.
Another service called Hazardous In-Flight Weather Advisories, or HIWAS, is available over select nav aids. You can find these listed on aeronautical charts with the letter H in the blue nav box. The HIWAS will transmit information on SIGMETs, AirMets, and convective SIGMETs.
Tom, in your book, Flying America's Weather, you write, pilots want a 1-800-CAN-I-MAKE-IT telephone number that they can call for an unequivocal answer to the weather's influence on the flight at hand. But I think we all agree that the only constant about weather is that it changes.
Yeah, a 1-800-CAN-I-MAKE-IT, that's kind of an oversimplification, but not much. I think people are a little bit intimidated by learning about the weather. They think of it as another block to check along their way to getting their private pilot certificate. But the fact is, it causes the most fatalities, and people are a little intimidated by the weather, so they want someone to sort of act as their alter ego and say, yes, you can go, it'll be safe. But we all know that it is a lot more complicated than that. It's meteorology is a science. You've got to say it's an imperfect science, but a science nonetheless. There's a lot to know about the weather. The only way to really stay abreast of it is to make it a part of your life and to be checking it every day and to become familiar with it. So I would say that. And gaining experience in flying in situations that are other than perfectly clear. Now, I gotta tell you that I think one of my students that I had, and I don't think I'm betraying a confidence, but we had this student, and he was concerned about clouds. Okay, he was going for his instrument rating. I was giving him instruction. So he was flying along, and there was an overcast, and there were a few clouds underneath. And so he had the hood on, and I was over in the right seat, and we're flying around. And he sneaks a peek, and he looks under there, and he says, I think I see a cloud. I think we'd better go back and land. And I said, well, you know, they're pretty far apart. You don't have to really worry about it. I can see pretty well. We'll go ahead and keep doing what we're doing. He said, no, I think we really should get on the ground. And I think a lot of people feel that way about clouds. The only way to overcome it and get over this 1-800, will I make it, is to put more responsibility and have more confidence in yourself in terms of your weather interpreting capabilities. That student subsequently went on to give himself the Indian name of Afraid of Clouds.
Okay. Well, Tom, what are the must-have reports and forecasts for pilots to get the big picture for the weather they'll be flying in?
The main ones are flight service, of course. You're going to have to get a legal briefing from flight service, but there's many online sources. There's all the DUAT sources. There's ADDS website, which is a very complete website. It's sort of a one-stop shopping. And there's many other internet sites that you can go to Unisys and Telecast, the private providers, WSI, AOPA has a weather web page that's very good. You can check that. There's just a multitude of sources on the internet. I think that unlike ever before, I just don't understand how we got along without the internet to give us our weather information. In the past, it was very, very limited and limited to the telephone briefing. Now, the internet seems to be the main way of gathering the information. And it does it in a visual way. Graphics are where it's at. So if you see graphics of a AirMet or a SIGMET, which are the number one things to check, first of all, that's what I check first of all, the AirMets and SIGMETs. Surface analysis chart. I look at the upper air charts to check about the wind patterns aloft. And I look at the weather depiction chart to see where the areas of VFR and IFR are located. And this gives you a very graphic look at the situation, a snapshot. You don't have to call up the text IDs of each airport along the route. So those are the main elements that I look at.
Welcome back to the studio and another review question. SIGMETs are issued as a warning of weather conditions potentially hazardous to which of these? A, B, or C? Your answer is B. A SIGMET advises of weather potentially hazardous to all aircraft other than convective activity. Items covered include severe icing, severe or extreme turbulence, dust storms, sandstorms, or volcanic ash, lowering visibilities to less than 3 miles. B is your answer. Okay, yet another topic, this time convective outlook. Let's get back in the classroom for that topic.
A convective outlook, AC, describes the prospects for general thunderstorm activity. Here's an example of a convective outlook chart. It's an outlook for the following 24 hours. Areas in which there is a high, moderate, or slight risk of severe thunderstorms are included, as well as areas where thunderstorms may approach severe limits. Outlooks are produced at the Storm Prediction Center, SPC, in Norman, Oklahoma. Pilots should use the outlook primarily for planning flights later in the day.
Okay, let's move along to another topic in this lesson. Surface analysis. Back to our classroom and your instructor for that topic.
The next topic is the surface analysis chart. The surface analysis chart depicts frontal positions, pressure patterns, temperature, dew point, wind, and obstructions to vision as of the valid time of the chart. Here is a pictorial representation of the various front symbols used on the surface analysis chart. The cold front is depicted by pointed triangles. The warm front is depicted with half-round circles. And here's an occluded front. It alternates pointed triangles and round circles. And this is an upper-level cold front shown by the hollow pointed triangles. Now here's an upper-level warm front indicated by hollow half-round circles. And lastly, the stationary front is indicated by a round circle on one side and pointed triangles on the other side. Now this graphic from Flight Prep and DoWatts depicts fronts, high and low pressure areas, and various precipitation areas. Now this next graphic, prepared by NOAA, shows a stationary front right here.
All right, here's your review question for surface analysis. The surface analysis chart depicts which of these three, A, B, or C? Read them carefully. Okay, well, the answer is A. Surface analysis chart depicts actual pressure systems, frontal locations, cloud tops, and precipitation at the time shown on the chart. All right, that's your answer. Let's move along. Next topic, weather depiction. Join your instructor in the classroom for that topic.
The weather depiction chart is a snapshot showing the weather going on across the entire country at one given moment in time. You can determine general weather conditions more readily with this chart than any other source. Therefore, the weather depiction chart is a good place to begin your weather briefing and flight planning. Here is a printed weather depiction chart as provided on your knowledge test. This chart is computer prepared from METAR reports to give you a broad overview of observed flying conditions. Here is a close-up. Now, note the location of the stationary front along this line. These charts are also available in color from DUWATS and NOAA and other weather providers. Let's look at some symbols on the depiction chart. The upside-down triangle means there is rain going on. This is the symbol for thunderstorms. Note this part of the T and a little lightning bolt going on there. This is a thunderstorm symbol. This filled-in triangle indicates a mountain, and there are some clouds that are topping over the ridges. Now here we find fog, or ground fog, 3 straight lines in parallel. Haze is depicted with 2 circles. And there's smoke down here. Here's our smokestack and our wavy line of smoke coming out of that smokestack. Now, drizzle here, ice pellets, snow, rain, freezing drizzle, and of course freezing rain. Here are the symbols for sky coverage. First, the clear circle means sky clear. This one with a quarter pie filled in represents sky scattered. And when 3/4 are filled, it indicates the sky is broken. A fully filled in circle indicates the sky is overcast. And finally, a circle with an X indicates the sky is obscured. Now here's a weather depiction chart. The legend in the lower right corner of the chart describes the method of identifying areas on the chart. Now here's how it reads. So shaded areas, IFR, with less than 1,000 feet and or visibility less than 3 miles, contoured without shading. Marginal VFR areas with ceilings greater than or equal to 1,000 to less than or equal to 3,000 feet, and or visibility greater than or equal to 3 to less than or equal to 5 miles. No contours. VFR areas with ceilings greater than 3,000 feet and visibility greater than 5 miles. Now, along this line, it shows where the fronts are located. You can see that right there. Fronts are not just surface features, they also exist in upper levels of the atmosphere. Now let's go to an airport. This open circle means you have clear skies. Now, here's another one. This one indicates the sky cover is broken. Now, here's one with the X through it. The sky is obscured in haze, fog, or smoke. Now, this airport is an IFR area. This filled-in circle means you have cloud cover, overcast skies. Now, this last one indicates the sky is scattered. Total sky cover is depicted by shading of the station circle. Cloud height is entered under the station circle in hundreds of feet above ground level. Symbols for weather and obscurations to vision are normally shown to the left of the station circle. Visibility in statute miles is entered to the left of any weather symbol. If visibility is greater than 6 miles, it will be omitted. Now, take a look at this area. You know it's IFR because it's enclosed and shaded. You want to go to this airport here, 3 1/4, and it's definitely cloud covered. The 3 1/4 miles you see in front of the fog symbol is the visibility at that airport. There is 3 1/4 miles visibility due to fog in cloudy conditions. Now another airport location, Las Vegas McCarran. Sky conditions here are broken because our location is partly filled in, but still a little bit of space left. The 250 indicates the conditions are broken at 25,000 feet. The last 2 numbers in the altitude are removed. Shaded areas indicate areas with ceilings less than 1,000 feet and or visibility less than 3 miles. Contoured without shading. Marginal VFR areas with ceilings greater than or equal to 1,000 to less than or equal to 3,000 feet, and or visibility greater than or equal to 3 to less than or equal to 5. No contours. VFR areas with ceilings greater than 3,000 feet and visibility greater than 5 miles.
Okay, let's take a moment for another review question. The marginal weather in central Kentucky is due to low which of these, A, B, or C? Well, in order to arrive at that, we've got to go to our weather depiction chart, find out where central Kentucky is on that chart. We've got it colored in there. Zoom in a little bit. After we zoom in, you can notice that the airport symbol is fully filled in, and the 30 beneath that symbol indicates a ceiling of 3,000 feet. Now back to our question. Marginal weather in central Kentucky is due to low ceiling. Visibility is normally entered to the left of the weather symbols, but since it's omitted, we know the visibilities are greater than 6 miles. Your answer there, C, ceilings. Okay, next topic. Radar summary. Back to the classroom.
Radar weather reports are of special interest to pilots because they indicate the location of precipitation with type and intensity. Also, it's the only chart that shows lines and cells of hazardous thunderstorms. The radar summary chart will yield a three-dimensional view of clouds and precipitation when used in conjunction with other charts and reports. Since radar detects only drops of ice particles of precipitation size, it does not detect clouds or fog. It shows you where radar echoes are returned across the country and the various points that have radar on them. Here's the summary chart. This is the valid time, 14:35. It's Friday, the 14th day of April. Now, here is the chart legend. Areas with precipitation are shown with contours, which indicate echo intensity. Echo heights are displayed in hundreds of feet, MSL. Tops are entered above a short line, while any available bases are entered below a short line. Movement of an area of echoes is indicated by a shaft and barb combination, with the shaft indicating the direction and the barbs indicating the speed. A whole barb is 10 knots, a half barb is 5 knots, and a pennant is 50 knots. Individual cell movement is indicated by an arrow that shows the direction of movement with the speed in knots entered as a number. Severe weather watch areas are outlined by heavy dashed lines, usually in the form of a large rectangular box.
Now, radar maps and animations, which you've mentioned on the internet, look so easy to use, and they're available for free everywhere, even on cell phones. Do you use those internet radar pages to help you with your go, no-go, or launch time decisions?
Yes, absolutely. That's because they come from NEXRAD images from ground-based NEXRAD weather radars. These are very powerful radars with very narrow beams. And what that means is that they can penetrate cloud masses much better than airborne weather radar and give you a correct depiction of the extent of the cloud mass. Airborne weather radar sounds nice to have it, but there are some big limitations, and that has to do with attenuation of the signal. This is where the signal from the radar is reflected back to the airplane prematurely. It cannot penetrate the entire cloud mass, and so it may look as though it's clear beyond, say, 10 miles ahead, but what in fact you may be seeing a much heavier radar return behind the clear area with airborne weather radar. With NEXRAD that you get from these sources, that's eliminated. There is no attenuation. Also, you have much more definition and much better resolution, and a better handle zooming out, zooming in on the big picture for the mass of clouds, for the front, for the storm, for the cells, whatever, that will enable you to make a decision as to whether you can circumnavigate it, whether it's so big that you should turn around. Issues like this are much easier to deal with that kind of weather information, the kind of NEXRAD imagery.
Here's an example of an online radar summary chart. Note the legend is color-coded, displaying echo intensity.
All right, let's take time out for another review question. We want you to refer to the summary chart for Area B. Question, what is the top of precipitation of the radar return? Which of these three answers? Well, we go to our summary chart. Zoom in on the B area there. A little closer yet, and you notice 240 equal to 24,000 feet MSL. We go back to our question, which is the correct answer, of course, C, 24,000 feet MSL. Another topic, this one, constant pressure. Join your instructor in your classroom.
Next up is the constant pressure chart. Meteorologists use these constant pressure charts using radiosonde data from which the charts are prepared. They're reported in terms of pressure. Use of pressure as the vertical coordinate simplifies many of the thermodynamic equations and computations. A constant pressure analysis chart is an upper air weather map where all the information depicted is at the specified pressure of the chart. Each of the constant pressure analysis charts, 850 millibars, 700 millibars, 500 millibars, 300 millibars, and 200 millibars, can provide observed temperature, temperature dew point spread, wind, height of the pressure surface, and the height changes over the previous 12-hour period.
We're back in the studio for another review question. This time out, what flight planning information can a pilot derive from constant pressure charts? Well, the answer here, what information? C, winds and temperature aloft, plotted at each reporting station on constant pressure charts, are observed temperature, temperature and dew point spread, wind, height of the pressure surface, as well as height changes over the previous 12-hour period. That's your answer then, C. All right, let's get another topic going here. Significant weather prognostics. Back to the classroom with your instructor.
Significant weather prognostic charts portray forecasts of selected weather conditions at specified valid times. Each valid time is the time at which the forecast conditions are expected to occur. Forecasts are made from a comprehensive set of observed weather conditions. The observed conditions are extended forward in time and become forecasts by considering atmospheric and environmental processes. This is the significant weather and prognostic chart which portrays forecast weather that may influence flight planning, including information on those areas to avoid and/or altitudes for freezing level and turbulence. Now, this four-panel chart is divided into two areas. We have analysis or depiction and prognostication or forecasting. 12 hours out from the current time and 24 hours out from the current time. The top part of this chart indicates ceilings and visibilities. The bottom part indicates surface weather conditions, where it's raining, where the fronts are, and what kind of precipitation there is. Now, the key to the prognostication chart is at the center. You can see right here, ceilings are less than 1,000 feet and are indicated by an enclosed line. Scalloped lines like this indicate ceilings 1,000 to 3,000 feet. And when you see this dashed line encompassing something, it's indicating there is moderate or greater turbulence. And this wavy line means freezing level at the surface, and the dashed line means freezing level above mean sea level. Now here's the 12-hour panel. It shows ceiling and visibilities. Notice here is a scalloped line. You can see that right there. You can also see this dashed line indicating a freezing level above the surface. This scalloped line indicates some type of ceiling. 24 hours out from the current time, you can see the key down here and the date. And here there are some serious visibility issues in the Pacific Northwest and throughout much of the Southeast. On the prognostic chart, 12 hours out, this indicates the surface panel. Now we can see pretty clearly right here, we have a cold front moving through the upper Midwest. and a trough line with a low. There's an indication here of some shower activity, a little bit of rain going on, shown by the symbol with 2 periods. You can see the 2 periods here, and also 2 periods in the Pacific Northwest, and even some showers popping up down in the Sacramento and San Joaquin regions of California. Everywhere else, pretty good VFR throughout most of Texas, and there are some obscurations and some type of precipitation going on down in the southeast. Now on the 24-hour chart, you can see the rain in the northwest is coming to an end right here. Shifting to the east to the Cascades, and of course a little shower moving into northern parts of Arizona. Still pretty nice though, again, throughout most of Texas. And then there are some clouds and obscuration down here in the Gulf Coast, and some weather in portions of the northern Great Lakes states. Here is the high-level significant weather prognostic chart. Same symbols as surface charts, but covers flight level 250 to 600. This high-level significant weather prognostic chart shows a much larger area. Again, same symbols as surface charts, but covers flight level 250 to 600.
Okay, let's take some time to cover a couple of questions in review. First one, interpret the weather symbol depicted in Utah on the 12-hour significant weather prognostic chart. Which of these answers will interpret that for you? Let's take a look at the chart. Over here, in the upper left panel of figure 20, 12-hour significant weather prognostics, the symbol indicates moderate turbulence. The 180 under the symbol indicates turbulence up to 18,000 feet. So if we go back to our question, interpret the weather symbol, it's A, moderate turbulence, surface to 18,000 feet. The 12-hour significant weather chart indicates that there's going to be turbulence up to about 18,000 feet. Answer A. Next question. We're going to ask you to refer to a figure, another chart here. The symbol on the U.S. high-level significant weather prognostics, indicated by arrow G, represents which of these? Well, let's go to the chart, find out where G is in the upper portion there. Zoom in a little. Zoom in again, and there we have that symbol. What does that represent? Back to our question. Arrow G represents B, the height of the tropopause. Tropopause heights are plotted in hundreds of feet at selected location. Heights are enclosed by rectangles. There you have it for lesson number 2, Weather Services.
Remember, understanding weather and how it relates to your aviation operations will not only enhance safety, but will also make your experience a whole lot more fun and efficient as you plan to avoid delays and diversions. For Stenbach Communications and ASA, this is Natasha Stenbach. It's been my pleasure to be your instructor for these weather lessons.